Hi, this is lesson 3.4, and in this lesson we are going to be relating parallel and perpendicular lines. Now, the first thing we want to talk about is the transitive property of parallel lines. That says if two lines are parallel to the same line, then they are parallel to each other. So let me just explain here a little bit. So it says if line P is parallel to line Q, okay? Let me get another color. And line Q is parallel to line R. Well, then we could say by the transitive property that P and R must also be parallel. So let's apply that problem. This is not on your note guide, but it's a great problem. It says the flag of the United States has 13 alternating red and white stripes. Each stripe is parallel to the stripe immediately below it. Explain why the top stripe is parallel to the bottom stripe. So we're going to use the transitive property here. So what you would do is you'd start out by saying that stripe 1 is parallel to stripe 2. Okay, because stripe 1 is parallel to what's right below it, it tells us here. And stripe 2 we know is parallel to stripe 3. So by the transitive property, then we could say stripe 1 is parallel to stripe 3. All right, and then we say, okay, what do we know about stripe 3? Stripe 3 is parallel to what's right below that. Actually, I'm going to go back here. I'm going to say stripe 1 is parallel to stripe 3. I'm going to repeat what we just said. And we know that stripe 3 is parallel to stripe 4. So we could say that stripe 1 is parallel to stripe 4 by the transitive property again. So now I'm going to repeat that. We know that stripe 1 is parallel to stripe 4. And we know that stripe 4 is parallel to stripe 5. So then we know that the stripe 1, the first one, is parallel to the fifth one. And we're not going to go through all of those, but you would just follow that pattern all the way down to show eventually that stripe 1 is parallel to stripe 13. And that would be using the transitive property of parallel lines. All right, now we're also, this isn't in your notes either, but I just want to show you this, and hopefully you remember back from Algebra 1 when you talked about the equations of lines. And one of the things that you learned is that when lines are parallel, they have the same slope. Remember, y equals mx plus b. Your slope is m, okay? So when both of these slopes are the same, the lines are parallel. And I graphed them, and you can see the orange line right here and the blue line right here. Those are parallel, okay? They have the same slope. Well, then hopefully you remember that when you learned that when lines are perpendicular, the slopes are the opposite sign and the reciprocal. So the slope here is 2 over 1. The reciprocal of that would be 1 over 2. And up here in the first equation and in the third, they're positive, so this would be negative. So then I graphed a line with a slope of a negative 1/2. Sure enough, there it is, this red line here. And that is perpendicular. In this program I use called GeoGebra, it's kind of a cool program. It will measure the angles, and this one's 90 and this one's 90. So this shows you that if you have a line, which remember the line cuts through these, it's called the transversal. If it's perpendicular to one line, it will be perpendicular to the next line when they're parallel. So that's kind of a proof of what we're going to do in the next theorem here. So we have two theorems. The first is a perpendicular transversal theorem, which says in a plane, if a line or transversal is perpendicular to one of two parallel lines, so in this example, if J is perpendicular to H, okay, then this line J will be perpendicular to the other line also. So if we know that H and K are parallel, and we do because they have those arrows, then if J is perpendicular to H, J will be perpendicular to K. So when we start out with parallel lines, if a transversal is perpendicular to one, it will be perpendicular to the other. The next theorem says in a plane, so remember in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So if two lines, so if we start out with having M and N, we just know they're lines, we're not told that they're parallel. But if there's a transversal that goes through, and if it's perpendicular to both of the lines M and N have to be parallel. Okay, so let's apply that. Determine which lines, if any, must be parallel in the diagram. Explain your reasoning. All right, so in this example, it says determine which lines, if any, must be parallel. So first of all, let's look here. Here we have S, and S looks like it's perpendicular to P, and it's perpendicular to Q. Okay, so it's perpendicular to this one, and it's perpendicular to this one. And it tells us if two lines are perpendicular to the same transversal, so both P and Q are perpendicular to S, then they're parallel to each other. So we would say P is parallel to Q, okay, because S is perpendicular to both. So let me erase that, and we'll do another example. Let's see, what else do we have? Here we have Q is a transversal, and it's perpendicular to which two lines? Oh, it's perpendicular to S and to T. So we would say that S is parallel to T because it has Q that is perpendicular to both of them. Now this one gets used a lot in practical applications. We're going to go look at one more example here real quickly, and then we'll do some practical applications here later. I want you to notice in both of these theorems that it says in a plane, that this is when this happens. So let's look at this next example because it'll explain why you have to use those words in a plane. So this says given AC, let me make my line thicker here. AC is this one and BD is this one, given that they are parallel, and they had those arrows there, so we know they're parallel. And also, make it a different color, and EC is this line right here, is perpendicular to AC. Would that mean that EC and BD are perpendicular? Well, we said that if a line is perpendicular to two lines, parallel lines, then it's perpendicular to both, but those two lines that are parallel must be in the same plane, it says. Okay, so that's looking at this one, in a plane. And remember, a plane is like a flat surface, so it would have to be like on this surface right here. So if the line that was given was that EG and AC are parallel, would it be true that EC is also perpendicular to EG? Well, then that would be true because AC and EG are in the same plane. But CE is not in the same plane as BD. So CE is not in the same plane as BD. So that would be false statement. All right, let's see how this would be used in a practical manner. A carpenter plans to install molding on the sides and top of a doorway. The carpenter cuts the ends of the top piece and one end of each side piece at 45-degree angles as shown. And then he puts them together. Will the side pieces of the molding be parallel? So will this side and this side be parallel? So basically we have this going on. All right, and this is the top. Now this angle would be 90 degrees because if you flip this 45 with this 45 and put them together, this is 45 and that's 45 together, that would make 90. Same over here, two 45s together add up to 90. Well, here's the deal. You have two lines here. The transversal is going through, and the theorem says if a transversal is perpendicular to two lines, then the theorem says that the lines are parallel. So yes, if these are both square corners, you would know that the lines, the doors are parallel. Very important for installing doors and windows, mainly doors, I'd say. Okay, next, you're going to do problems like this in your homework. If X and Y are parallel and Y is perpendicular to Z, what do you know about X and Z? Here's the thing, guys. With something like this, draw a picture. So X and Y are parallel, or they look, they're kind of parallel. My drawing's not the best, but they're parallel. I'll put an arrow there. That means they're parallel. All right, now you have Y is perpendicular to Z. So I'm going to draw Z, and it's going to go through like this. So this is Z, and it's perpendicular to Y. Well, if this is the case, what do you know about X, which is this one, and Z, which is this one? Well, the theorem says that if you have two parallel lines, if a transversal is perpendicular to one, it is perpendicular to the other. So you would say X is perpendicular to Z. All right, so the next one, it says, we have a couple different things going on. It says, is B parallel to A? So let's look at this, B and A, B and A. Okay, so we have transversal D going through, and look, D is perpendicular to both. So if a transversal is perpendicular to two lines, the lines are parallel. So for this one, we would say yes, D is perpendicular to A and B. Okay, so that A and B are parallel. And then it says, is B perpendicular to C? Well, let's see here. We have to do some reasoning. I'm going to erase some lines here. Is B perpendicular to C? So I want to know this right here, if these are perpendicular. So if lines C and D are parallel, we have to look at that first. C and D. Well, are they parallel? Let's see. Do we have enough information? Well, let's take a look over at transversal A. Look at there. That meets both of the lines at a 90-degree angle. So for that one, okay, we have C is parallel to D because A is perpendicular to both. Sorry, my writing's not the best with this, because A is perpendicular to both. Okay, so since these lines are parallel, we have that established. C and D are parallel. Well, now, because B is perpendicular to D, then B is perpendicular to C. So you would say yes, because B is perpendicular to D. Okay, so that's that. Then we know that those are perpendicular. So we're using both proofs there. Now, this is important to understand because of this problem right here that says think about a plan. One traditional type of log cabin is a single rectangular room. Suppose you begin building a log cabin by placing 4 logs in a shape of a rectangle. What should you measure to guarantee that the logs on opposite walls are parallel? All right, so first of all, if you measure this angle and that's 90, and you measure this angle and that's 90, you would know that these lines here are parallel, okay? And then these are square corners. But you would need to have one more angle, because if you just lay the other log here, and it could be slightly crooked. I'm gonna make it really crooked, okay? And you definitely could see you're not gonna have a square there, okay? But if you were to measure one of the corners, and if this is 90 degrees, that would mean that this would also have to be 90 degrees if you have parallel lines. So you would need 3 corners measured in order to know that you have a square. All right, and then you have a worksheet to do here in this lesson, worksheet 3.4. And let me just do a few problems to get you started. It says BC is parallel to DF, and DF is parallel to GH. So what's the relationship between BC and GH? Well, we're going to use a transitive property, and we would just say BC is parallel to GH. BC is parallel to GH, and that would be by the transitive property. Okay, and so go ahead and work on that. Here you have a proof, and I've done gotten that started for you. You have to prove, okay, you're given that X and Y are perpendicular, okay? You're given that, and that Y and Z are parallel. So you have to prove that X is perpendicular to Z also. So basically what you would say is that you know that the measure of angle 1, which is this one, is 90 because it's a corresponding angle. You know that this is 90. So if these lines are parallel, corresponding angles are 90. They're both 90. And by the definition of perpendicular lines, and since this is 90, X is perpendicular to Z. All right, and then I want to give you one more quick little tip here on another problem. Where is that at here? Oh, number 9. The diameter of a circle is the same as the side of a square. So okay, this is just review from probably 8th grade. Remember, the diameter is the length around. So this we'll call D. It's the same as the side of a square, so I'm going to call that D. Now it tells us that the perimeter of the square is 16. So if you add up all the sides, the 4 sides add up to 16. And remember, a square has 4 congruent sides. So 16 divided by 4 equals 4. So each of these sides is 4, which means this is 4. Then you have to find the circumference. So the circumference is 2 pi r. That's your formula. Well, what's the radius? Now remember, here's your hint, the radius is half of the diameter. So I'll let you try to figure that out. All right, thanks for watching. Let me know if you need help.